Hello everyone, in this video I am going to discuss the topic. The name of the topic is derivatives. So first of all I will discuss the definition, then after discussing the geometrical meaning of the derivative. So the tangent line to the curve y equal to fx at the point PAFA is the line through P with the slope m is the slope. So how can find the slope? Limit x to a f of x minus f of a upon x minus a. So we will see that what is the mean of this. Okay, so let us suppose that we have a function y equal to fx. Okay, so in this function there are 2 points p and q which are lies on the function. Okay, so first of all we will see that p point is here fixed. Okay, q point is moving. First of all it is here, so yellow line is passing through p and q. Okay, then q is moving another place which is also on the function here. So green line is also passing through p and q. Okay, now q point is here, so red line is also passing through the point p and q. Now we are seeing that q points is moving towards the point p. Okay, after some times this line, this straight line will passes through the, if point q tends to p, if q points tends to p, then this white straight line will pass through the point p and will touch the curve. Okay, so we can say that this line is become the tangent. Okay, so this line. So now how can find the tangent, equation of the tangent line we will see further, but this is called the slope. Okay, limit x tends to a f of x minus f a upon x minus a, this is called the slope. Here we will see that what is the mean of this slope. We have in a point, this is point a, we have in a point a, and this point is the x which is equal to a plus h, means the distance between a and x is a plus h. Okay, h. So we have in a curve p and q are both point here. The value of at a point, this is the function y equal to fx. Okay, so at a point a the value of the function is f of a, so this coordinate become the coordinate a f a, and this point is x, so this coordinates x fx. So now we basically slope is equal to m equal to tan theta. Okay, so we will take theta, so this is the perpendicular, this is the base, so f of x minus f of a upon x minus a. Okay, now we are seeing that this is becoming a secant line. We can say this line is secant, this is also secant, this is also secant, but after some time this line become a tangent line. Means here we can say that this is the point. So the derivative of the function at a point c, so limit f of c plus f minus of c upon h, limit h tends to 0. That means our point q, in this graph we can see that q is moving towards the point p, so means h is going to 0. So f of c plus h minus f of c upon h, if the limit exists finitely, then we can say that this is the derivative of the function. So means slope is basically the derivative of the function. Okay, so the tangent line to y equal to fx at a point a, f of a is the line through a f a whose slope is equal to f dash a. Okay, the derivative of slope is basically m equal to f dash a. Okay, so the derivative of the function f dash x equal to limit x tends to 0 f of x plus x h minus f of x divided by h. So this limit should be exist but finitely exist. Okay, definition is that a function f is differentiable at a point a if f dash a exists. Okay, so next question is that how can a function fail to be differentiable? So here is we see the definition of the derivative. If this limit does not exist, that means functions fail the derivative. function failed to be the differentiable if this limit does not exist. So how can we say that geometrically by the seeing the graph, this graph is not differentiable, it is differentiable or not? So how can we say that? Let us suppose that we have a graph, we have this type of graph. Okay, so these are the points where we can draw infinitely many tangents. So but we know that tangent at a point of any point of the function is unique, but here the slopes are infinitely. So we can say that at this point function is not differentiable. At this point function is not differentiable because there are infinitely many tangent exist at that point. Okay, so we can take an example, fx equal to mod x. Okay, so the graph of the fx equal to mod x is like that. Okay, this is the graph of the mod x. Okay, so we will check that the derivative, this function is differentiable at a point, sorry. So we will check that this function is differentiable at a point x equal to 0 or not. So we will apply this definition at a point 0. So we will apply this definition. Okay, so limit as tends to 0 f of c plus h minus f of c upon h. Okay, our function is x. Okay, and value of c is 0. So we can say limit as tends to 0 f dash c equal to, okay, so f dash 0, we have a value of the c 0. So f of h minus f of 0 upon h. Okay, so our function is modulus x. So how can define this function? We can open this function is like x positive and minus x if x is negative. Okay, so we will put here f dash 0 equal to limit as tends to 0, value of f of is mod h minus value of at 0, when we put f of 0 equal to mod 0 or mod 0 equal to 0, so 0 upon h. So we have seen this limit of this function is in the previous lecture. We have seen the limit of this function is exist or not. So I will tell you again, limit as tends to 0 plus h by h equal to 1, and limit as tends to 0 minus h upon h equal to minus h. Left hand limit and right hand limit both are not equal. So we can say that the limit of this function does not exist. So that means f dash 0 does not exist, means fx is not differentiable at a point x equal to 0. Okay, so we can also define further examples like fx equal to x square at a point x equal to 0, if this function is differentiable or not at a point x equal to 0. So basically where is the function failed to differentiable, where this type of the cusp become where the numbers of tangents are infinitely exist. So we can say that at that point function is not differentiable. Okay, so I think we should stop here. In the next video I am going to discuss some applications of the derivative and derivative, how can we trace the function, trace the curve? Okay, thanks.